everybody. In this video, we're going to talk about the multiplication algorithms for whole numbers. So let's start off by multiplying by one digit. So if I have 213 times 3, that means that I'm making 3 copies of the number 213. So to model this, I would first start off by showing my number 213. And I'm going to use a chip abacus for this, but obviously you could also use base 10 blocks as well. So to model 213, I'm going to have 2 chips in my hundreds column, 1 chip in my tens column, and 3 chips in my ones column. And when you're teaching this to your students, you're going to explain that we're going to make 3 copies of this entire number. But the easiest way to do this is to take 3 copies of each place value individually. So if I have 3 copies of 3 ones, well, the total amount that I have is 9 ones. And if I make 3 copies of 1 10, well, then I have 3 tens. And if I have 3 copies of 2 hundreds, then I have 6 hundreds. And again, you could show this with base 10 blocks if you wanted to do that. And so this is what it looks like when you're multiplying by one digit. But this is a very easy example where none of these numbers were greater than 10. But if they are greater than 10, then you'll have a situation where you have to exchange like 10 ones for a 10 or 10 tens for 100. And so this is where the intermediate algorithm is useful. Because if you have 245 times 6, this time I'll model it with blocks. So if I have 2 hundreds and 4 tens, so here's 1 10, 2, 3, 4, and then I have 5 ones. So I have 2 hundreds, 4 tens, 5 ones, and if I'm multiplying by 6, that means that I'm making 6 copies of this. So I could do this with my blocks, and I could say, okay, if I take all of this and I make 1, 2, 3, 4, 5, 6 copies of this number, then I can just look at how much is in each place value. So especially if your students have their times tables memorized, they'll know that 6 copies of 5 ones is going to give you 30 ones. And you can write this down just in your answer column with a 3 in the tens column, because if you have 30 ones, you can regroup those 30 ones into 3 tens. And then you can do the same thing for the tens, and you can say, okay, well, if I have 6 copies of 4 tens, that means I'm going to have 24 tens. 20 of those can be converted into hundreds, so I'll have 2 hundreds and 4 tens, and so that is 240. And then for the hundreds, if I make 6 copies of 2 hundreds, then I have 12 hundreds. So 10 of those hundreds will become 1,000. 2 of them will just stay as hundreds, and I have 1,200. Then we can add all of these together and say, okay, with the 30 ones and the 24 tens and the 12 hundreds, how much is there all together? Well, there's 0 ones, 7 tens, 4 hundreds, and 1,000. And that would give us the number 1,470. And obviously, as you're working with blocks, you can show this more visually as well. So when I said 5 times 6 is 30, I could regroup these into tens. So there's 1 10, here's another 10, and here's another 10. And so that kind of visually shows why I wrote down 30. And then with the 24 tens, I can regroup those as well. So there's 100 and another 100. And so this shows that 24 tens there. So you have 2 hundreds and 4 tens. And then with your hundreds, when you had 12 hundreds, if you group those together, you have 1,000 and 2 hundreds. And so that kind of visually shows where these numbers come from. And then once your students are feeling confident with this, then you can teach them that there's a shortcut to this that doesn't require as much writing. And that's the standard algorithm. And I'll model the standard algorithm with chips, but as always, you could always model them with base 10 blocks as well. So I'll go through and solve this same problem, but with the standard algorithm. So you would teach your students and you would say, okay, Well, if I make 6 copies of 5 ones, that's going to give me 30 ones here. So, because 5 times 6 is 30. And 10 of those could be regrouped into a tens block. And another 10 of those could also be regrouped into a tens block. And these could also be regrouped into a tens block. And so the way we'll write that is we'll say, well, I have 0 in my ones because they all ended up getting regrouped into tens. And then I have 3 extra tens in my tens column. And then I say, okay, well, how many tens do I have? Well, I have 4 tens and I'm making 6 copies of them. So that's 24 tens. Then I also have these 3 tens that got carried. And so the 24 tens plus the 3 tens will give me 27 tens. So 20 of those will be able to be converted into hundreds blocks. So I didn't draw this in a way that made it super easy to group the tens, but these can be regrouped into tens or into a hundreds block. These can be regrouped into a hundreds block. And then I have 7 tens that are outside of that. So I'll put a 7 in my tens column and a 2 in my hundreds. And one thing you'll want to point out to your students is that these 2 hundreds are not getting multiplied by 6, because the only thing that's getting 6 copies made of it is the original 2 hundreds. And so when we take those 2 hundreds and make 6 copies of them, then we have 12 hundreds plus these 2 hundreds here. And so if I say, okay, well, since I have a total of 14 hundreds, I can exchange 10 of them for 1,000, and then I have 4 hundreds left over. And so that means I'm going to put a 4 in my hundreds, and since I don't have any other thousands to copy or anything like that, then I'll just put a 1 in my thousands. And this is how you can help your students visually see how the standard algorithm for multiplication works. And then once students are comfortable multiplying by 1-digit numbers, then you'll move on to multiplying by 2-digit numbers. And a rectangular array can be a really helpful way to model 2 digits multiplied by 2 digits. So to model 34 times 12, I'll model the number 34 with 3 tens and 4 ones that are all arranged in a straight line. And then I'm going to make 12 copies of this. And when I explain it to my students, I would say, okay, we're going to start by just making 2 copies. So we'll make 2 copies and then we'll make 10 copies. So we're kind of going to break up the copy making process by place values. And so we say, okay, so here's 1 copy, here's 2 copies. And we're going to go through and figure out how much is in that number as it is. So we'd say, okay, well, the number of ones is 8. And you can point out that 4 times 2 equals 8 because we're making 2 copies of the 4 ones. Then we can say the number of tens that we have is 6, so we have 60. And that's because if we had 3 tens and we made 2 copies of it, then we would have 60. Then we're going to say, okay, so that's the amount that we have with 2 copies. And if we added them together, that would be 68. But I wasn't asked to just make 2 copies of this number. I was actually asked to make 12 copies. So I need to make 10 more copies. So I'll take this number, 34, and make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 copies. And when I do that, when I make 10 copies of this first 10, that becomes 100. And so I'm going to set that over to the side for a sec. And then these 10 tens also made 100. And then when I made 10 copies of this 10, that also made 100. And then I can also do the same thing with my ones. And I can say, okay, well, these 10 ones, that made a 10. Whoops, and it got off balance a little bit, but that's going to go over there. And I'll turn this sideways so that it's consistent with that. But basically these ones I can regroup. In fact, I'm just going to regroup all 4 of these all at once really quick. But when you're doing this like with physical blocks, it would be better to like kind of group them as they're still arranged in a rectangle. But I'll go ahead and do that right here. So when you make 10 copies of any one, it makes a 10 block. And so our rectangle that we started off with is going to look kind of like this. And if you're doing this with physical blocks, it's a little bit easier to show the rectangle, but you can also do it with the applet. And so basically this shows that we made 2 copies of 34 and then we made 10 copies. And then you can figure out how much is in the 10 copies. And you can say, okay, well, when I had 4 ones and I made 10 copies of them, that became 40 because each of the ones, when you made 10 copies, turned into a tens block. And when I did my 3 tens and I made 10 copies of them, well, each 10 turned into a hundreds block. And so that became 300. And so basically what you're teaching is you're saying, okay, well, when we make 2 copies, I have to make 2 copies of the 4 ones and 2 copies of the 3 tens. And that's basically like this part of the rectangle right here. And then you say, okay, but then I also have to make 10 copies of my 4 ones, which is this part, and 10 copies of my 3 tens, which is this part. And all together, that's going to be what 34 times 12 is. And so then we can add all of this up and we can say, well, 8 plus 0 plus 0 plus 0 gives us 8 ones. 6 tens plus 4 tens gives us 10 tens, which we can change into 100. And then 100 plus 300 gives us 400. And so this rectangular array shows us that the answer to this problem is 408. And the reason why we don't have 4 hundreds here is because these 4 tens and these 6 tens have not been recombined together in this rectangle structure. But that comes out more through when you're adding up, like the 6 plus 4 and like having to carry that, than when you're actually doing the multiplying. So a rectangular array can be a really helpful way to visualize a 2-digit number multiplied by another 2-digit number. And it also kind of previews the idea of area when you're finding the area of a rectangle and explains why you would need to multiply the length times the width. So the process that I showed you on the last slide would be the first step to teaching kids how to do 2-digit multiplication. Where you're basically saying like, okay, each place value we're going to make copies of. So like the 4 ones, we're going to make 2 copies of that, which makes 8. Then we have 3 tens, and when we make 2 copies of that, that gives us 60. Then you can say, well, when I have 4 ones and I make 10 copies of that, that gives me 40. When I have 3 tens and I make 10 copies of that, that gives me 300. And then you add them all up. But there is a shorter way to write this that doesn't require like 5 lines of calculation. So the way that we do that is we say, okay, well, I'm going to start off by making 2 copies of 34. And you do have to do this in 2 steps where you say, okay, well, 2 copies of 4 ones is going to be 8 ones. 2 copies of 3 tens is going to be 6 tens. So basically in this shortcut version, we're combining these 2 rows into a single row. And this row is representing what 2 copies of 34 is. Then you would say, okay, then I need to make 10 copies of 34. Well, 10 copies of 4 ones is 40, and 10 copies of 3 tens is 300. And so again, this is kind of combining these 2 rows into a single calculation. So we're thinking 2 copies of 34 and 10 copies of 34. And then we add these together and we get 8, 10, carry the 1, that gives us 4. And we get the same answer as the first algorithm. But this is a shortcut because you don't have to write out as many steps. And then this can lead to the final algorithm, which is the standard algorithm. And so the standard algorithm starts off the same as the intermediate algorithm 2, where you say, okay, I'm going to make 2 copies of the number 34. So 2 copies of 4 is 8 ones. 2 copies of 3 tens is 6 tens, so you get the 68. But then the second step is different in the sense of how you think about it. So the writing it out doesn't actually change too much, but it's how you think about it. So on this one, we think about it as 10 copies of 34. And on this one, we're going to think about it as 1 copy of 34 in the tens place. So if I made 1 copy of 4, that's 4. 1 copy of 30 would be 30. So 1 copy of 34 is 34, but we're going to write it in the tens place. So kind of the idea of this is that like this 1 represents a 10, but you can think about it as 1 times 10. And you multiply the 34 by 1, and then you multiply by 10 and put a 0 at the end. And this is easier. I mean, like in this case, it's not that bad because we're multiplying by a 1. But if this is like a 5, sometimes students have a hard time thinking about what 50 times 30 is. But it's easier if they think about 5 times 30 and then multiply by 10. So the idea is that you take this number and multiply by this, kind of ignoring the place value, but you put the last number of your answer in that place value and then put a 0 at the end. And so again, you get the same answer. You'll still get 8, 10, carry the 1, get a 4. So the process looks about the same for the standard method versus the intermediate one or intermediate 2. But it's the way you're thinking about it. Because in this one, you're thinking about it as 10 copies of 34. On this one, you're thinking about it as 1 copy of 34 times 10. And so the way you would explain it to students is slightly different. So that's how the standard algorithm works and kind of how to build up to it. And then the last thing I want to go over is the lattice method. So if we were doing the standard algorithm for 4,967 times 35, the way we would think about this is we're first going to think about 5 copies of 4,967. So you'd say, okay, well, like 5 copies of 7 is 35. So I'll have 5 1s and 3 10s. Then 5 copies of 6 10s gives me 30 10s. But then I also have these 3 10s that were carried over. So that would give me 33 10s, which gives me 3 in my tens column and 3 hundreds, because 30 of those tens can be converted into hundreds. And then if I make 5 copies of 9 hundreds, that's 45 hundreds. But then I also have these 3 hundreds. And so that makes a total of 48 hundreds, 8 of which will stay in the hundreds column, and 40 of them will be converted into thousands. And so I'll have 4 thousands. And then I originally had 4 thousands that I was making 5 copies of. So if I make 5 copies of the original 4 thousands, that's 20 thousands. And then if I add on my 4 other thousands, that gives me 24,000. So I'll have a 4 in my thousands and a 2 in my 10,000s. And again, this kind of goes back to what we were talking about with the CHIP abacus when we were just multiplying by one number. That like regrouping idea is the same here. It's just that we're dealing with a much bigger number. Then if you're using the standard algorithm, the next step is to say, okay, well now I need to make 30 copies of 4,967, but I'm going to think about it as making 3 copies and then making 10 copies. And when I make 10 copies, it's basically just going to put a 0 on the end of the number. So I'll put that 0 in there. And now I'm just going to think about making 3 copies of 7 rather than doing 30 copies of 7. So 3 copies of 7 would be 21. So I'll have a 1, and then I'll carry a 2 to the next place value, because 3 copies of 7 would be 21. So I have a 1 in my tens column because when I multiply by 10, it will shift the place values over. Then 3 copies of the 6 tens would be 18, plus the 2 that we carried over would be 20 tens. So I'll put a 0 here. And the reason why it's not going in the tens column, again, is because ultimately we'll multiply by 10, which will shift all the place values over 1. So we have 20 tens, put a 0 in that one, and then carry the 2 up to the next place value. Then 3 copies of 900s would be 2700s, plus the 200s we carried would be 2900s. So I'm going to put a 9, not in my hundreds column, but in my thousands column, because multiplying by 10 at the end will shift everything over. And then I'll carry my 2 over to the next place value. Then my last step is to make 3 copies of the 4000s, which will be 12,000s, plus the 2000s will give me 14,000s, but the whole thing is shifted over one place value because I'm going to multiply by 10 at the end. And so that gives me 14 10,000s. So I have a 4 in my 10,000s and a 1 in my hundreds thousands. So basically, this part of the number right here is what you would get if you did 4,967 times 3. Then everything gets shifted over one place value because this 3 is actually a 30. And so we would multiply by 10 to get the place values in the right spot. And so when we add those all up, we end up with 5, 4, 8, 13, carry the 1. 1 plus 2 plus 4 is 7, and 1. And so our answer would be 173,845. And then there is another method you can use instead of the standard algorithm, and that's called the lattice method. So the way that the lattice method works is you write out the numbers you want to multiply on the sides of a box, and then you draw diagonal lines through the box to make it so each box has 2 parts. And then you fill in those boxes by multiplying the row and the column numbers together. So for example, when you make 5 copies of the number 7, you get 35. When you make 5 copies of the number 6, you get 30. When you make 5 copies of the number 9, you get 45. And when you make 5 copies of the number 4, you get 20. And then you do the same thing when you make 3 copies of all of the numbers. So when you make 3 copies of 7, you get 21. When you make 3 copies of 6, you get 18. When you make 3 copies of 9, you get 27. And 3 copies of 4 gives you 12. And then what you do next is you add up all of the diagonals. So 5 plus nothing is 5. 1 plus 3 plus 0 is 4. 2 plus 8 plus 3 plus 5 is going to be 10, plus 3 is 13, plus 5 is 18. And if it's bigger than 10, then you just carry it to the next diagonal. And then you add all those up. So 1 plus 1 is 2, plus 7 is 9, plus 4 is 13. And then I'll carry the 1. 2 plus 2 plus 2 is 6, plus 1 is 7. And 1 plus nothing gives you 1. So I added up these diagonals there. And then if you look at that, you can see that this right here is the same answer that we got with the standard algorithm. And the process that we went through is basically the same, because when I filled out this bottom row of boxes, basically I was doing all of the steps that I did here, because 5 copies of 7 was 35, but I wrote it in this box versus over here, I wrote a 5 here and a 3 up here. And then when I did 6 times 5 is 30. I did 33 because I added together this 3 and this 0 to get 33 here. And then basically like so on and so forth. And then the upper row of boxes corresponds to this step that I did here. And then with the way that the box is arranged, it basically lines up all the place values along the diagonal. So then you can just add up all those place values. So that's how the lattice method works. If you guys have any questions, let me know. And I hope that you guys have a great day.